Okay, today we're going to talk about 2.9, two variable absolute values or absolute value functions. We have a lot of stuff that we're going to do in class. What I want you to remember is this guy right here, f of x equals a absolute value of x minus h plus k. This is really important. You're going to need to know this, okay? Each of these is changing the parent function. The parent function is just f of x equals the absolute value of x. And what that looks like is this guy right here. Has a slope of 1 and a slope of -1. This is the parent function, okay? When x is 0, the absolute value of 0 is 0, so that's 0, 0. When x is 1, the absolute value of 1 is 1. When x is -1, the absolute value of -1 is 1, so that's why it travels like this. When x is 2, absolute value of 2 is 2. When x is -2, the absolute value of -2 is 2. So that's why we get this guy right here. Okay, that's the parent function. Now the movement is how this point right here, which we call the vertex, changes. Okay, so the vertex is going to move left and right based on our h value. H moves the vertex left and right. So here's the tricky part. It says minus h. So you got to really look at what h is. If h is positive, meaning it says -3, then it's going to move to the right. If h is negative, meaning it says +3, it's going to move to the left. So it's kind of confusing because it looks opposite than it really is. So if I have something like f of x equals absolute value of x minus 7, this is moving my graph, my vertex, 7 units to the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7. The vertex is now right here. It still has a slope of +1 and -1. So the slope didn't change at all. It just moved it 7 units to the right. So this 7 is 7 units to the right. Okay? If it told me something like f of x equals the absolute value of x plus 2, again, h is actually x minus h, right? So it's minus -2. My h value is -2. So since h is negative, that means I'm going to the left 2. I still have a slope of 1 and -1. So that's the new function. It just moved to the left 2. Okay? So h moves you left and right. K moves you up and down, the one on the outside, and it is exactly how it looks. So if I have something that tells me f of x equals the absolute value of x plus 2, well, what's happening here? It's moving up 2. The vertex is now right here, still a slope of 1 and -1. So that's what we're looking at. If it tells me f of x equals the absolute value of x minus 3 plus 1, now this is moving to the right 3 and up 1. So on my graph, I'm going to move to the right 3 and up 1. My vertex is now right here, still a slope of 1 and -1. Hopefully that makes sense. Gonna just continue on, okay? So the a value, h moves you left and right, k moves you up and down. A value is your slope. But we don't call it slope, we call it vertical stretch or vertical compression, or we reflect across the x-axis. A vertical stretch happens when a is greater than 1. A vertical compression happens when a is less than 1. Notice that neither of these are equal to. Equal to means that it's no change. Greater than is a vertical stretch, less than is a vertical compression. However, we treat it as the absolute value of A. So that means we ignore a negative sign for these portions, okay? A negative sign reflects it across the x-axis. So A equals negative. So if I looked at something that told me f of x equals negative 3, absolute value of x plus 1, absolute value minus 2. The negative is going to reflect it across the x-axis, which I'm going to write as RAXA for reflected across the x-axis. The 3 is going to vertically stretch it by a factor of 3, which I'm going to write as VSBAFO, vertically stretched by a factor of 3. So that's this guy. This is going to move it to the left 1, and this is going to move it down 2. So that's our total change to the parent function. That's what we're looking at, okay? So we're going to go back to our parent function. We're going to move down 2 to the left 1. There's our vertex. It's vertically stretched by a factor of 3, meaning that it's 3 times steeper or narrower, okay? Vertically stretched means that I'm pulling the original one like this, which makes it more skinny, but it's also reflected across. So instead of going like this, which it normally would do, it's going to come down here. But it's going to come down here and be 3 times skinnier, or it's going to have a slope of negative 3 over 1. So that's what we want to look at here, okay? I know that this is kind of confusing. I'll go over a couple more, and I'll show 3 more examples and then do 3 more graphs. If you understand it and you think you're okay, please watch it anyways, just because these are kind of confusing, okay? So f of x equals negative 1/2 x plus 3 minus 1. That's the first one I'm going to do. 2/3 x minus 1 plus 3. X equals 7/8. 7/8, yeah. X plus 2 minus 1. Okay, so the first one, this 1/2 is vertically compressing it by a factor of 1/2. The negative is reflecting it across the x-axis. So that means vertically compressed means that it's going to actually get 2 times wider. It has a slope of 1/2. But it's reflected across, which means it has a slope of negative 1/2. Okay? This guy inside of here, the 3 is going to move it 3 units to the left, and the negative 1 is going to move it down 1. This one is 2/3, so it's going to be vertically compressed by a factor of 2/3. This 1 is going to move it to the right 1, and this 3 is going to move it up 3. This one vertically compressed by a factor of 7/8. This 2 is going to be to the left 2, and this 1 is going to be down 1. So I'm going to graph them each. So the first one, it moves from here down 1 and to the left 3. Down 1 and to the left 3. Ignore that little point that I made. That was an accident. Now, it's reflected across the x-axis, which means instead of going up like this, it's going to go down like this. And it has a slope of negative 1/2, which means I'm going to go down 1 and over 2 in each direction. So this one is really twice as wide as the other one, which is what vertically compressed means. I'm pushing it in. If I push it in, it gets wider. Okay? The next one, number 2, it's moved to the right 1 and up 3. So this is my new vertex. It's vertically compressed by a factor of 2/3. In other words, it has a slope of 2/3. So I'm going to go up 2 and over 3, 2 and over 3. And then the last one, down 1 to the left 2, vertically compressed by a factor of 7/8. And that's it. So 7/8, slope of 7/8 and negative 7/8. We're going to do a bunch of these in class tomorrow. If you have questions, let me know.